Hello. Today we're going to be talking about engineering change orders as a part of the document control process. You're going to learn what document control is and what makes it so important, how to implement a document control system, and how a document control system leads to improvement in your product. Document control is essentially risk mitigation. There are common problems that are associated with poor document control. For example, ordering the wrong revision of a part, building an assembly using the wrong type of materials, having failures in the field because a change designed to prevent an intermittent failure wasn't properly or consistently implemented, struggling to figure out where the latest drawing or procedure is and where to get it. The universal solution to all these problems, and many more similar to them, is document control. You need to design a process to create, store, and make changes to information that you need to build your product. So, what are the elements of good document control? Documents need to be stored in a safe central location, the single source of truth. Everyone can view these documents, but only one designated person, the document manager, has the permissions to change documents. This is the person who handles the truth. However, they can't be a dictator or an authoritarian making these changes. There needs to be a process or a tool to control the changes to documents. That is the engineering change order. The engineering change order is the meat and potatoes of the document control process. There are 5 steps to a good engineering change order. First of all, you need to identify the need for the change. Second of all, draft that change, review and approve the change, implement the change, and finally communicate the change to the relevant parties. Now, it may seem simple these 5 steps may seem simple to you, but there's actually a lot that goes into them. So I'm going to break them down in my next slides. First, identify the need for the change. For example, production may identify a manufacturing improvement. Your design doesn't change at all, but you may need to update your work instructions. Or you might find a new supplier that can provide a higher capability optic. Your form, fit, or function, your design doesn't change, your work instructions don't change, but your form, fit, or function is changed and you have a higher output. And you may want to notify your customers of this improvement to your product by updating your product brochure. Third, you may be reviewing trends in your RMAs or DMRs and identify design improvement to stop failures that you're seeing on the floor or in the field. That may require a part drawing change or a work instruction change as well. Now that you've identified the need for a change, you need to go ahead and draft that change. Take your document and update it. You can see here that we've identified a revision history to the document, so it's easy to identify. Here's the rev that was made, and you flag that same change in the document. You update the rev level, save under an ECN number, and it's also often useful to add a title and a document number to your document as well. This revision history is great because it shows you the lifetime of changes to the document over time. You can use this not just on part drawings like this, but also your work instructions or your procedures as well. Now you need to actually review and approve the change. So how do you do that? First, identify the stakeholders based on the scope of the change. What I mean by that is perhaps if you're making a work instruction change to a product, your customer or your sales department won't care because the output of the laser is exactly the same. It's just simply a manufacturing process. So they don't need to review and approve the change, but your engineering department certainly should. Next, identify the change impacts. Every change may result in many impacts to your other processes. For example, if you update a work instruction, will training on that work instruction need to be updated as well? Or is it a simple follow the steps in the procedure? Will incoming inspection plans need to be updated if you change a mechanical aspect of a component? Will this be a customer service upgrade for already fielded systems? Our earlier example of an RMA trend for systems that you're seeing fail, perhaps one of those systems comes back and you go ahead and preemptively make this upgrade so that they don't see that failure that you fear will trend into their system as well. When you're making a change to mechanical components, you also have to think about the parts that you already have on the floor, the parts you have in stock, the parts you have on order with a supplier. Will those be able to use as is, or will you be able to rework them, or will they have to be scrapped out? So once you've thought through all this, you need to go ahead and communicate that change and the impacts to the stakeholders. Create a reason or communicate the reason or need for change, communicate the description of the change, and provide them a draft of the new version of the document for them to review. There's a lot that goes on in this step, and it may be hard to wrap your head around how you'll communicate all this. So I provide an example document or form that I use for my review and approval step. You can see here I've got my need for change, my description of change. I have drop downs for if I need to update training or not, for whether I need to rework or scrap stock, and for whether someone's required for an approval for this particular ECN. This is a form I easily put together using Adobe Pro. Next, go ahead and actually implement the change if you have approval. You want to take your draft document and move it to the single source of truth location where everyone in your company will know to look for it. Don't just delete your old document though, save it in an archive location. That often is useful for customer service and engineering reference. And then go ahead and make those additional steps we talked about. Update your stock, your work in progress, your incoming inspection plans, provide your training, whatever else may be necessary. Now that the change has been implemented, you need to also make sure to communicate it. The document manager notifies all relevant employees of the change, and these may not be the same employees as those who approved it. For example, engineering may approve a change to a work instruction, but it might not be important to them once that improvement has actually gone into effect. However, the technicians on the floor following that work instruction certainly need to be notified of the change because they might have printed out copies of the work instruction that need to be destroyed and replaced with new copies. It's also important at this step for the purchasing department to work closely with the suppliers for this change. You need to understand whether your suppliers are going to be able to implement a change. You need to communicate with them and work with them as to what they can do with the components they may already have built up and have in stock for you. It's a lot of steps, we worked through it, and finally, our ECO is complete. To review again, first you identify the need for a change, draft that change, review and approve the change. Of course, it may be possible not to approve a change, in which case you can cancel the change or provide a feedback and redraft your change, going through the process again. Once you get approval, go ahead and implement and communicate the change. So there's more to just ECOs for document control, however. You need to think to yourself, should a document be controlled? When would that be true? Well, perhaps you want to keep that document safe. You want to keep a record of the changes. You want to keep everyone working to the same version, and you want to find it quickly. So what are some examples of that? Typically, you'll see control documents include work instructions, specifications, drawings and procedures, forms, and even you may want to keep your regulatory requirements and standards under your internal document control. Some common characteristics of controlled documents include a document title, number, and revision level, a process for making changes, that's the ECO process, a common format so that all your documents have a professional company template that you use, a revision history table as we saw before on the document, and you want to store them in a document library at a central location everyone can access that has the current revisions and limited edit access. It's also important to know that you may have different levels of document control. Typically, during rapid development and prototyping, you don't go through as detailed of an effort in controlling the change. Perhaps even only engineering is required for approval to a change. However, once you get to higher volume production, you want to go, it's recommended to use these additional steps as we've outlined earlier. So, how do you get started? First of all, there are many ERP or software solutions for document control. Perhaps you already have an ERP and this is additional capability that you can tack on. However, if that's not the case, there are quick, easy, and effective homegrown solutions you can implement. All you need is something like a server with read-write permission controls. You can put whatever sort of file structure you want in there. An approval tracking form, an ECO log, an archive location. We've already shown you an example of an approval tracking form. And here's an ECO log where you can see we have the ECN number, the part description, the quick top-level change description, what project or model, the engineer responsible, who requested the change, urgency level, date opened, date closed. This is great because you can search by the part number and see the revision history again for any component or document. So, how does document control lead to improvement in your product? Well, it ensures that once found and implemented, solutions are permanent. It helps customer service track upgrades and keeps records of build information for legacy RMAs. And it drives coordination and communication between departments. I recommend reviewing your ECNs on a weekly basis. Get all your department heads together in a room and go through the changes. That way, you may be able to identify, well, this change is a manufacturing improvement for production, but it actually makes our product more difficult to service and it may not be worthwhile. Or this is a needed change to a component. However, our current supply for that component does not have the capability to make the change. So we'll need to go out and get new quotes, which may impact production timetables. Overall, organization defeats chaos. This is a great improvement to your processes. In summary, you've learned that engineering change orders are a critical part of document control, which is the way you minimize risk by ensuring that everyone in your organization is marching to the beat of the same drum. You can implement document control easily through simple and practical methods. And a minor change to a simple part can have a significant impact on the quality of your product. Having a document control process can provide you with the consistency you need to build quality into your products, train new employees, reduce rework and scrap, and thereby increase profitability. Thank you.